Hello students, so let's try to solve this particular problem. This is from IIT JAM 2024 examination and this is from quantum mechanics. In this problem, it is a probability density is given and we have to identify which one of the following potential is correct with respect to their energy given. So it is given the particle is moving along x-axis and approaches x is equal to 0 from x is minus infinity with a total energy E. It is subjected to a potential Vx for a time t tends to infinity. The probability density of the particle is symmetrically given by this one. Then which one of the following potential is correct with your energy? Also you have to see what should be the energy and what should be the potential. So students, it's a wonderful problem. What we have to do, we have to take each case and then we have to see which one of the following is correct one. So let us try to go step by step. So we have to just go for step by step into this particular problem. So the first one is all about, we have to just go for this one. So first one is my potential is something like this. This is my potential Vx, this value is V naught. And this is my x. You have this potential is going to truncate at some finite value. So it is just after then it is 0. But energy is something like this. So this will be my energy. So what you can see, this region is classical allowed region. This region is classical forbidden region. And this region is again classical allowed region. So what will happen? Once particle will come here, it will collide and it will reflect back, but there is chance that it can decay into this classical forbidden region, and once particle will come into this region, it has equal probable into this region. So what will be probability density? So the probability density in this case is something like this. So here you have incoming and outgoing, so we have sinusoidal, and once we will just go for decay, and after then once particle will cross, it will straight line. So obviously this is not a correct one. Let's try to go for second one. In the second one, so this is my option number A. In the second one, what we have basically sort of a step potential. So this is a step potential, it is going up to this, and my energy is less than V naught. My energy is less than V naught. This is V naught, my energy is less than V. In this problem, in this case, this energy is also less than V naught. So again, you can see this will be classical allowed region. The particle is free. This will be classical forbidden region. Only two regions are there. So what will happen? We can just plot the probability density. Here particle will come, it will collide and it can go back. So you have both the incoming and reflective particles, and once particle will come into this side, it will just going to decay something like this. So what will be my probability density is something like this. So this is also not a correct option, whatever given in our the four options. So this is your option number B. Let's try to go for option number C. So when we are going for the option number C, then option number C is again we have step potential. So this is my V naught. But what we have energy which is more than V naught. More than V naught. So all regions are classical allowed region. All regions are classical allowed region. So what will happen? The particle will come from minus infinity. At this point, it may either cross or it may reflect. So in this region, you have incoming as well as reflected wave. So here you have a completely sinusoidal in nature. And once you will cross, you have a just transmitted particle. So you have just this one. So I think this one is the correct option, but let's try to go for option number D, which is also very interesting, which is really very beautiful. So what we have this kind of situation. So this is my potential V naught. This is your Vx versus x. Again, here we have Vx versus x. So what will happen? Again, my energy is something like this. So all regions are classical allowed region. So what will happen? This is very interesting. The particle is coming from left. At this particular point, it can reflect back. So it is incoming and outgoing, incoming and reflective particle. And in this region, there is also incoming and reflective particle, but momentum of a particle into this region is less comparable to this one. So what will happen here? You have also incoming and reflective particle from this particular point, but getting the probability is higher with respect to this one. So amplitude will be higher into this region, and once it will cross this thing, it will be again become the free particle, and only you have transmitted particle. So what should be the nature? The nature will be something like this, and once we have this will be something like this, and once we will cross, then what will happen? You will be just go for this one. So this type of probability density is for this one. So students, you have to just draw this particular thing. The concept is very simple. What should be the classical forbidden region? What should be the classical allowed region? Where is your momentum is going to increase? Where your momentum is going to decrease? Accordingly, you can have your de Broglie wavelength, and all this concept you can use this particular problem. So once we will go for this one, then obviously option number C is the correct one. So it's a wonderful problem. You have to practice with yourself.